You know, for as long as we have looked up at the stars, we've dreamed of living out there among them. It's this deep-seated part of who we are, showing up in our myths, our movies, and, well, now in our actual science. But that dream is forcing us to ask a really practical question. If we're gonna become a multiplanetary species, where in the world do we actually go first? So today, we're gonna dive into that huge debate and some of the surprising science behind where humanity's next home might be.
And let's be really clear about the stakes here. The late, great Stephen Hawking put it in pretty much the starkest terms possible. This isn't just about some grand adventure for its own sake. To some of the smartest people on Earth, this is about the survival of our species, full stop. The idea is that with all our eggs in this one planetary basket, we're just incredibly vulnerable. So the question of where to go next, it's not trivial. It might just be the most important question we ever have to answer. All right, so here's our game plan. We'll kick things off with the big debate itself. Then we'll look at the case for the moon, and right after that, the case for Mars. From there, we're going to get a serious reality check with the massive, planet-sized problems facing any colony. Then we'll explore a pretty radical third option before finally trying to figure out what our real destination should be.
So, where do we go? For decades, this has been a really passionate and, let's be honest, sometimes pretty heated debate in the whole space community. And yeah, there are a lot of potential places to go in our solar system, but the conversation, it almost always boils down to two main candidates. On one side, you've got our closest celestial neighbor, the moon. And on the other, you've got that little red dot in our night sky, Mars. They really represent two completely different philosophies for how we expand into the cosmos. You've got the practical first step versus the giant, ambitious leap for humankind. And this really lays out the core trade-offs perfectly. I mean, the moon is right there. It's a 3-day trip. If something goes terribly wrong, help is, relatively speaking, right around the corner. But it's a harsh, airless world with super low gravity. Mars, on the other hand, is this grueling 6 to 9 month journey away, but it offers these amazing possibilities. A thin atmosphere we could actually work with, more Earth-like gravity, and the potential for a real, true second home. Okay, let's start with the case for the moon. The people who are pro-moon argue that trying to just jump straight to Mars is, frankly, reckless. They see the moon not as the end goal, but as this essential training ground, a place where we can learn how to live off-world before we venture out into the deep black. This really nails that stepping stone argument. Think about it. When you're learning to survive an environment that is actively trying to kill you, do you want your supply line to be 3 days long or 9 months long? On the moon, we could talk to Earth with almost no delay. We could test out life support, construction ideas, resource mining, all while knowing that if a critical system fails, we aren't stranded millions upon millions of miles from home. And this brings up the other side of the moon argument, the money. The moon isn't just a test bed, it could be a massive industrial park. The low gravity makes launching stuff from the moon into space way, way cheaper than from Earth. We could build enormous solar power stations, mine water ice for rocket fuel, or even harvest something called helium-3, a rare isotope that could power clean fusion reactors in the future. The moon could actually become the economic engine that pays for everything else we want to do in the solar system. So, okay, the moon is the practical choice. But what about the inspirational one? Let's turn to the other contender. For the people who champion Mars, the goal isn't just to build a workshop in our backyard. The goal is a second genesis for humanity. And here it is, the core of the Mars argument, what people often call the lifeboat theory. The moon is just too close, too tied to Earth. If some catastrophe were to hit our home planet, a base on the moon might not make it either. But Mars could. It could be truly independent. With its own resources, a protective, even if it's thin, atmosphere and higher gravity, it has the potential to become a self-sustaining branch of human civilization, a true backup for our entire species. And when you really get into the nitty-gritty, Mars has some serious advantages for long-term living. It has carbon, nitrogen, all the essential elements for life. Its gravity, only about a third of Earth's, is still more than double the moon's. And that is a huge deal, because we know that long-term exposure to super low gravity can cause major health problems, like your muscles wasting away and your bones losing density forever. Plus, a day on Mars, a sol, is only 39 minutes longer than a day here. Psychologically, for colonists, that's a massive, massive benefit. Okay, so we have two really compelling visions, right? The moon is our practical base camp, Mars as our new home. But now,
Now we have to leave the debate hall and step into the world of harsh physics and brutal engineering, because both of these incredible dreams slam headfirst into some really, really big problems. It's the simplest question, and it's also the most terrifying one. We can talk about grand visions and economics all day long, but when that hatch finally opens on a world where the air is poison and the environment wants you dead every single second, could we actually pull it off? This isn't just a weather forecast. This is a threat assessment. On the left, you've got a clear view of Mars. On the right, that's the exact same view, just 1 month later, completely swallowed by a global dust storm. And these aren't just sandstorms. We're talking about fine dust getting kicked so high into the atmosphere that it can literally block out the sun across the entire planet for weeks, maybe even months. And this NASA simulation shows you what that looks like from the ground. The sun just fades away to this tiny, powerless little speck. If you're in a colony that relies on solar power, this is not an inconvenience. It is a life-threatening, system-wide blackout. This is, in fact, almost exactly what NASA's Opportunity rover saw back in 2018, before its solar panels were starved of light and it went silent forever. And here's the hard data from NASA to back that up. Just look at the drop-off. If you're at the mid-latitudes, your solar power can plummet by 2/3. If you're at the high latitudes, you could lose 75% of your power. Can you imagine trying to run life support, heaters, and water recyclers on just a quarter of the energy you designed for? It makes relying on solar power an absolutely terrifying gamble. So if the environment is a huge problem, what about our gear? Well, this number is pretty sobering. A NASA analysis found that on past missions, the actual time and effort people spent fixing the life support systems was 22 times higher than what the engineers had predicted. Our life support is way, way more fragile than we like to admit. And this quote from a NASA report really puts it all into perspective. On Mars, you can't call Houston for a spare part. There is no Amazon Prime delivery for a new water pump. There is no going home early. Every single thing you need for a multi-year mission has to come with you, and every single system has to work, or be fixable right there on site, with zero outside help. Reliability isn't just a goal, it's the only thing that separates life from death. Okay, so the challenges of living on the surface of another planet are just immense. The environment is hostile, our bodies break down in low gravity, and our technology is super fragile. And all of this has led some thinkers to propose a completely different path. What if, instead of trying to adapt ourselves to a deeply alien planet, we just built our own? And that brings us to the O'Neill cylinder. It was first proposed by a physicist named Gerard K. O'Neill back in the 70s. It's not a ship, and it's not a base on a planet. It's a habitat, an artificial world built in the vacuum of space. The whole idea is to build these massive rotating cylinders that use centrifugal force to create artificial gravity on the inside surface, completely sidestepping all the health problems of living on a planet. So here's how it would work. You build these enormous structures in space, maybe using materials you've mined from the moon or from asteroids to avoid the crazy cost of launching it all from Earth. Then you spin them up just fast enough to create a perfect 1G of gravity, exactly the same as Earth. You use these giant mirrors to direct sunlight inside, which gives you total control over the day-night cycle and seasons, with no planetary dust storms to ever worry about. The inside would be vast, thousands of square miles, enough space for an atmosphere, soil, forests, rivers, towns, you name it. You're not just surviving on another world, you are living in a custom-built paradise with perfect Earth-like conditions. And this brings us to a really critical shift in how we think about this. The whole idea of an O'Neill cylinder, it forces us to reevaluate our initial question. Maybe we've been so focused on choosing between two places, the moon or Mars, that we've totally failed to ask a much more fundamental question. So let's just quickly recap the key takeaways here. The debate is so much more complicated than just Moon versus Mars. We've seen that any attempt to live on a planet's surface faces these incredible hurdles, from planet-blotting dust storms to the brutal math of just keeping your equipment running. And that reliability issue, more than anything else, is the true barrier to long-term survival off Earth. And this leads us to the ultimate takeaway. Maybe the real choice isn't about which planet we should adapt to, but whether adapting is even the right strategy in the first place. Maybe building a perfect habitat from scratch is the safer and ultimately better way to go. And that's the question I really want to leave you with. As we look up at the stars and we start planning our future, what are we really looking for? Is the goal just to put our footprints on another world's soil, no matter how hard it is or what the cost is? Or is the goal to create sustainable, prosperous, and safe new homes for humanity, wherever and however we can build them? The answer to that question is going to define our future as a species.